Hello everyone, welcome to the course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about the next layer in the OSI reference model, that is transport layer. This is the fourth layer in OSI reference model. And in previous sessions, we already discussed the three layers. Those three layers are the physical layer, next data link layer, network layer. These three layers already we discussed in previous sessions. Now we are going to moving on to the next layer, that is transport layer in the OSI reference model. First, let us see the overview of today's session. We will discuss about the introduction about the transport layer. What is transport layer? What are the functionalities that are going to be provided by the transport layer? That we will see. And next we will going to discussing about the transport services. What are the services that are going to be provided by the transport layer, like end-to-end delivery, addressing, reliable delivery, flow control, multiplexing. All these services we will going to discuss in today's session. First, let us see the introduction. The transport layer, it is the fourth layer from the top. The OSI reference model is four total. It is having the 7 layers. OSI is nothing but open system interconnection. It is having total 7 layers. The first layer is the application layer. First layer is application layer, and the second layer is the presentation layer. Third layer is the session layer, and the fourth layer is the transport layer, and the fifth layer is network layer, and the sixth layer is the data link layer, and the seventh one is physical layer. These are the 7 layers of the OSI reference model. Here, this transport layer is the fourth layer from the top. So, the main goal of this transport layer is mainly for providing the communication services directly from one application to another applications that can be running the different host. See how it is going to be. Here is the sender, here is the receiver. Suppose sender want to send some message to the receiver. First, he has to select some application. Suppose he want to send the message using the application is WhatsApp application. By using the WhatsApp, he want to send the message to the receiver. So, where this receiver receives that message? In the application only. That application is the WhatsApp application only. Through the application WhatsApp, he is going to be receive the message. Means from this application to this application, we are going to send the message. That is nothing but the application to application. We are going to directly communicate the message. Means it is going to provide the communication service directly from one application to another application that is running on the different host. How it is? Here, sender network is different and the receiver network is different. Then also we are going to directly communicate from one application to another application. That is going to be provided by the transport layer. If the network of the sender is different, the receiver network is different, then also we can send the data directly from sender to the receiver. Suppose the sender network and the receiver network both are same, then also we can send the message. That is the transport layer. And transport layer, it takes the data from the upper layer. Here it is the upper layer, that is the in TCP/IP, we can call these 3 layers as the application layer only. Application, presentation, session, these 3 we can call it as a combined as a application layer. So here we can take the data from the upper layer, that is application layer. Whatever data we are going to take, that can be breaks into the form of the segments. That is in the form of bytes. And that can be handed over to the lower layer. That lower layer is the network layer. The transport layer that are going to be handed over to the network layer in the lower layer. See this picture here. Here is the application layer. This application layer providing the information that are going to be transferred to the transport layer. Here transport layer is having the protocols are the TCP and UDP. Transmission control protocol, user datagram protocol. These 2 protocols we will discuss in next classes. and these two protocols we are using in transport layer. And next, whatever segments of data that are going to be transferred to the network layer, this is the internet layer is called as a network layer only. It is in the form of packets. It is in the form of segments. Here we are going to send and receiving the data in the form of segments only. At the same time, this transport layer is the first one. It is going to break the information. So in the application layer only, we are sending the data. Using the application, we are going to sending the data. Here in the form of information only, in the form of data only. Whatever information is going to be there, that are going to be divided in the form of segments. That is in the transport layer only. So this is the first layer. The data is going to be divided in the form of segments. And this is supplied by the application layer, that are going to be in the form of segments. And this layer mainly talking about the data must be received in the same sequence which it was sent. How the sender is sending the message, the same way it is going to be received by the receiver. Then only that reliability delivery, that is called as a reliability delivery. And this layer is mainly talking about the end-to-end delivery. Here is transport layer is also called as a end-to-end delivery, process-to-process delivery, process-to-process delivery, application-to-application delivery, application-to-application, and next one is the peer-to-peer. These all names is called as a transport layer only. Transport layer is also called as end-to-end layer, process-to-process layer, application-to-application layer, and peer-to-peer layer. These are called as a transport layer only. Here it is end-to-end delivery. From my application end to I am going to send to the my friend application end. That is end-to-end delivery. At the same time, all the server processes that are going to communicate over the network using TSAP, that is Transport Service Access Point. This information is going to be sent to the transport layer. Here it is transport access point, that is nothing but the port. It is called as a port. It is having the port numbers. Based on that only we are going to sending and receiving the messages. Here this is mainly offers the peer-to-peer one, end-to-end communication between the process on the remote host. Means here already I told between the process is also called as process-to-process delivery. Between one application to another application, we are going to from transport layer to receiver transport end. From this end to I am going to send the data to the receiver end. We are going to sending and receiving the data. Here it is NSAP is nothing but network service access point. Here it is network service access point. Here it is the sender side and this is the receiver side. Here we are sending the data. This way we are going to send the data. This way we are going to receiving the data. This is the main functionalities of the transport layer. And the next one is the transport services. What are the services? Mainly it is going to be provided. The transport layer services, it is going to mainly similar to the data link layer. In previous sessions, we already discussed the data link layer services like framing, error control, flow control. All are the services of the data link layer. And these similar services it is going to be provided by the transport layer also. So here, but some differences are there in between transport layer and the data link layer. Here the data link layer provides the services within the single network only. It will going to provide the service. And coming to the transport layer, it is going to provide the services inter-networks, means between the networks it is going to be provided by the transport layer. It is in the data link layer only within the single network. And coming to the data link layer, it controls the physical layer only. And coming to transport layer, it controls all lower layers. So in the previous case, already I told that OSI reference model is having the total 7 layers, right? Fourth layer is the transport layer. Fourth one is the transport layer. And the fifth layer is the network layer. And the sixth layer is the data link layer. And the seventh one is the physical layer. These are the physical layer. These are the layers of OSI reference model. These are the layers. So here the data link layer, the lower layer is only physical layer to the data link layer. Data link layer only controls the physical layer. And coming to the transport layer, the lower layers are the network, data link layer and the physical layer. These three layers are the lower layers to the transport layer. So the transport layer controls these 3 lower layers. That is the meaning of these 3 lower layers. And the services that are going to be provided by the transport layer are the 5 services. Those are the end-to-end delivery, addressing, reliable delivery, flow control and multiplexing. These are the services are going to be provided by the transport layer: end-to-end, addressing, reliable delivery, flow control and the multiplexing. First we will discuss one by one services. First one is the end-to-end delivery. What is end-to-end delivery? I already told transport layer is also called as end-to-end layer. Means from my application end to receiver application end, my friend application end, I am going to send the message. That is the meaning of end-to-end. My WhatsApp application end to, I am going to send the message to the receiver WhatsApp application end. That is the meaning of end-to-end. Application to application, we are going to send the message. And the next one is the reliable delivery. Next service is reliable delivery. So here it is going to provide the reliability services mainly by transmitting the lost or damaged packets. Means here, suppose when you are sending the data from sender to the receiver, there may be chance of lost the packets or damaging the packets. By retransmitting that lost packets or damaged packets, we can overcome that lost or damaged packets. So by retransmitting the packets. So here the reliable delivery happened in 4 aspects. Those are the error control, sequence control, loss control and duplication control. These are the 4 ways of the reliable delivery. First one is the error control. What is error control here? Error control is nothing but, this is the first aspect. It is already we discussed in data link layer also. There also we discussed error control. Error control means we are talking about the error detection as well as the error detection is there as well as the error correction also going to be happen. First we have to detect the error where the error is going to be there. Then we have to correct the error. Those are called as the error control. So here in data link layer, what is the main difference between data link layer and transport layer? Then both are using error control only in data link layer and transport layer. But the difference is data link layer error handling mechanism only in node to node delivery, node to node error free delivery. And coming to transport layer, it is end to end reliability. Means suppose I already told that suppose transport layer is there. Transport layer. Next one is the network layer. Data link layer. Next one is the physical layer. Physical layer, whatever data is there, that is going to be in the form of bits. And the next data link layer, whatever data is there, that is in the form of frames. That is node to node. From one node to another node, we are going to sending the frames. And coming to the network layer, we are sending that in the form of packets. These packets means from one network to another network. That is called as one host to another host, we are going to sending and receiving the packets. And coming to the transport layer, we are sending in the form of segments, the data in the form of segments, that is end to end, from one application end to another application end. That is the transport layer. Here transport layer is end to end, data link layer is the node to node delivery. So see this example here. Here this is one node, this is another node. Here suppose this is also one node, router, this is one router, this is another router. So here in between nodes, if there is any error, it can be detected and corrected by the data link layer. It can be checked by the data link layer. Suppose within the network, here this is the network. Suppose within the network, if any error is going to be happen, that can be overcome by using the transport layer only. It will not going to be checked by the data link layer. It is going to be checked by the transport layer only. That is the main difference in between the data link layer and the transport layer. So here that is only it is going to be there. Within the network, it can't going to be accepted by the data link layer. That can be identified by the only transport layer only. So here it is called as the end-to-end mechanism that can be ensure the packets has going to be arrived correctly and correctly or not, it is going to be checked. And the next one is the sequence control. In reliability delivery, next one is the sequence control. Already we completed error control. Error control means it is talking about the error detection as well as the error correction. And next one is the sequence control. Sequence control is talking about, so mainly when we are sending a message from the sender to the receiver, that is in the form of sequence. Here we are giving some sequence number to particular message. Then receiver will understand in which way the sender is sending the message, whether he is receiving correct sequence or it will going to be checked. That is the sequence control. So here the sending end mainly responsible for that the packets received from the upper layers that can be used by the lower layers. And the receiver end, what it is going to be do? The various segments of the transmission can be correctly reassembled or not, it is going to be checked. See this example here. Here the sentence is same like hang him, not, comma, leave him. Here the next sentence is hang him, comma, not leave him. Here the meaning of this one is different. The meaning of this one is different. So the sequence is very important when we are sending some message. That is the main thing of reliability delivery. And the next one is the loss control. That is the third one in reliability delivery. Loss control means when we are sending the message, there may be chance of loss some packets. That is the one more thing to overcome that. The loss control, how it is going to be happen? Transport layer ensures that all the frames that are going to be arrived at the destination or not, it is going to be checked. On the sending side, all the fragments, whatever fragments are going to be there, that are going to be given sequence number by the transport layer. It will give some sequence number. Whenever we are sending the message, we are giving some sequences. Sequence 1, 2, 3 like that. We are dividing that in the form of segments, right? That is going to be in the form of segments. So, suppose where the receiver is going to be received that message. Suppose some sequence, here we are sending sequence 1, 2, 3, 4. But the receiver is received only sequence 1, 2, 4. So, here we can identify easily the 3 packet is going to be lost. The third sequence is going to be lost. We can identify easily based on the sequence number only. That is the loss control. And coming to the next one, the duplication control. This is the fourth aspect in the reliability delivery. So, duplication control also, that can be also identified by the sequence number only. Suppose same sequence, here sequence 1, sequence 2, the sequence here only, here I am writing here. Here sequence 3 is also there. Then after also it will receive sequence 1. Again it is going to be received. So we can identify easily based on the sequence number. Here it is the duplicate sequence. It will going to be identified easily. Sequence numbers are mainly going to be identify the duplicate packets or the lost packets in the reliability delivery. That is the main thing of the reliability delivery. Error control, sequence control, loss control and duplication control. And the next one, third transport service is the flow control. So this flow control already we discussed in data link layer also. Flow control. What is the meaning of the flow control here? Flow control means what exactly? Suppose the capacity of the sender. Capacity, we are talking about the capacity. Capacity of the sender and the capacity of the receiver. Here is the sender, here is the receiver. Suppose sender capacity, within 1 minute, the sender can send 10 packets. Suppose the receiver capacity, within 1 minute only, he is going to be receive only 2 packets. The capacity, here the capacity of the sender and receiver is same? No. So means here there may be chance of overwhelming of the data. Suppose here also, the receiver capacity also, here the capacity of the receiver also 10 packets. Here we can easily send and receiving the data. Suppose here the sender capacity is only, here this capacity of the sender is only 2 packets. The receiver capacity is the 10 packets. Then also we can send the data easily only, because the sender capacity within 1 minute he will send only 2 packets. But the receiver, the capacity is 10 packets. Here also it will be okay. But when the sender capacity is more compared to the receiver capacity, there the problem will occur. Suppose here it is going to receive only 2 packets. Then the problem will occur. So means Here the receiver is overloaded with the too much of data. So because within 1 minute he is going to be sent 10 packets. Next minute again he is sending the 10 packets. Next minute again he is sending the 10 packets. But the receiver capacity per minute only he is receiving only how many packets? Here it is going to be received only 2 packets. Then the whatever data is going to be, that is going to be overloaded at the receiver side. So that is how this flow we are going to control. That is the flow control mechanism. So how it is going to be controlled? See here, it is going to be the main responsibility of the transport layer is nothing but to control the flow. How it is going to be controlled? Using the sliding window protocols. What are the sliding window protocols we discussed previously? Those are the go back and protocol, go back and the selective repeat. These protocols we are going to be selective repeat ARQ for sliding window protocols. These two protocols mainly for used for the flow control mechanism only. How the flow we are going to control by using these sliding window protocols. And these sliding window protocol, that is byte oriented rather than the frame oriented. This is about the flow control in transport services that is going to be provided by the transport layer. And the next one is the multiplexing. What is multiplexing here? So this is one of the services of the transport layer to improving the transport efficiency we are going to use. Here the multiplexing is talking about combining the multiple data signals. Combining the multiple data signals or streams into a single signal. Here the combining all multiple data signals into a single signal that can be sent over a single or shared medium. Single shared physical medium is nothing but multiplexing. This multiplexing is divided into 2 ways. That is upward multiplexing, downward multiplexing. First of all, what is upward multiplexing? Upward multiplexing is nothing but multiple transport layer connections are there. Here multiple transport connection, 1, 2, 3 connections are going to be there. Multiple transport connections that are going to use the same network connection. Then next layer, this is the transport layer. This is transport layer. This is the network layer. So here the multiple transport layer connections are there that are going to be used the single network connection. That is nothing but upward multiplexing. So it is more cost effective. The transport layer mainly use these several connections bound for the same destination along with the same path. This is nothing but the upward multiplexing. And coming to downward multiplexing. What is downward multiplexing? Here downward multiplexing, one transport layer connection. Here it is only, here it is a transport layer. It is transport layer. It is a network layer. So here only one transport connection is going to be there that are going to be used as the multiple network connections. Reverse to the upward multiplexing. That is nothing but the downward multiplexing. Here the downward multiplexing mainly allows the transport layer to split the connection among the several paths to improve the throughput. At the same time, this type of multiplexing used where the network capacity is low. Where the network capacity low or slow, that time only we are going to use this type of downward multiplexing. That is the meaning of the multiplexing. And the next transport service is the addressing. What is addressing here? Addressing is nothing but according to the layer model. Addressing means the sender and the receiver. The two are there. The data first it is going to be generated by the application layer. That is, it is the here this is one device. This is another device. Sender device and receiver device are different. Already we know that one. Here it is when we are sending the message, we have to select the application. From this application to we are sending the message to the receiver application end. Means the data is generated by the application and the machine must be transmitted to the correct application on the another machine. Suppose here I am using the application is WhatsApp. That message should be come in the receiver side also in the WhatsApp only. Then only that will the correct address. Suppose here I am using the application is WhatsApp application. Is it received by the email? Is it possible? No. So it is not a correct addressing. Means whatever data in which application we are sending the data, same application only the receiver also receives the message. Then only that addressing is the correct addressing. That is nothing but the application to application addressing. So in this case, addressing is provided by the transport layer. Who will provide this addressing? By using the transport layer only, we are going to send the message same application ended to the same application. Here the transport layer mainly, so here we will talking about application layer protocol into a single layer known as the application layer. At the same time, this transport layer mainly providing the address specified as a station or port. Whatever address is there, that is nothing but in the form of port. The port variable represents a particular TS user of a specified notation, that is nothing but TSAP. Already I told that transmission service, transport service access point. Each station has only one transport entity. Every station is having only one transport entity for sending and receiving the data. The transport layer protocol need to know which upper layer protocols are going to be communicating using the addressing only. This is the main transport service of the transport layer. See here it is the transport layer. Here we are going to sending the data. Here it is the sender. Here it is the receiver. We are going to send the data in this way. The receiver has to receive in this format using the addressing only. Means in which application we are using for sending the data, same application the receiver has to receive the message. That is the meaning of the addressing. And the next one is the summary. Coming to the summary, in today's session we discussed the introduction about the transport layer. What is transport layer? Like why it is the fourth layer, what are the functionalities, all we discussed. And next we discussed the transport layer services. The services like end-to-end delivery, addressing, reliable delivery, flow control, multiplexing. All these services are discussed in today's session. Thank you.